Hey everyone, here's a video to help you through the test review. I realize it's kind of late, but hopefully maybe it will give you a last minute study before the test. So here we go. Number one, graph each function and identify the domain and the range. So starting off, I would point out my h and k. And remember that h does the opposite of what it appears. So h is -1, k -3. That means we're going left 1 and down 3. We're going to shift that at the end. So then I would rewrite my function. I'm going to do just the basic function, which basically means ignore your h and k and just do the rest. And then I need to plug in some numbers for x. I'm going to pick numbers I know the square root of. Whoopsie, I don't know what happened there. Sorry about that. Try that one more time. So I want to pick, again, numbers I know the square root of. So 0, 1, and 4. Those are nice and easy. Then when I put them in, I have square root of 0 is going to give me 0. And 1/2 times 0 is 0. Then I plug in 1. And the square root of 1 is 1. And once again, doing weird things here. Okay, so square root of 1 is 1. Multiply it by the half there. 1/2 times 1 is 1/2. Then I have the square root of 4, which is 2. And 2 times 1/2 is going to give me 1. So 1/2 here and 1. Then we're going to go put those points on the graph. 0, 0, 1, 1/2, and over 4 up 1. Remember, 0, 0 is the smallest point we can have because we can't plug in those negative numbers for x. If I was connecting, I would connect going towards the right. But since I can't yet because I haven't shifted, let's shift. So I'm going to be shifting left 1, down 3. So every point goes left 1, down 3. So we're going to end up connecting these blue dots. So left 1, careful on the down 3. That's 1, 2, 3. You're still at a halfway point there. And left 1, down 3. And here's where we connect those points going to the right. Again, weirdness. Sorry about that. And that gives us our graph. Then when we go to fill in domain and range for the domain, looking for the smallest x value, that means all the way to the left. The smallest x value, or the point furthest to the left, is right here. And that x value is at -1 for x. So I would do -1 all the way to infinity. For the range, I'm looking for the lowest point on the graph, which happens to be that same point. And the y value there is -3. So I would say -3 and then all the way to infinity. So we always go smallest to biggest. And that's the graph. Next, this one, we are going to do basically the same thing. So I have h equals 1. Remember the opposite of what it looks like. K equals 4. That means I'm going right 1 and also not down, excuse me, up 4. And then I'm going to rewrite my function. Remember, basically just ignore h and k. And I'm going to pick numbers I know the square root of, so 0, 1, and 4. This time I'm going to plug them in a bit quicker. When I plug in 0, the square root of 0 is 0, so I get 0. When I plug in 1, the square root of 1 is 1, so I get -2 overall. And when I plug in 4, I get 2, so I get -4 overall, like so. And then we're going to put those on the graph. We have 0, 0, 1, -2, and 4, -4. Then I'm going to shift, going right 1 and up 4. So right 1, up 4, right 1, up 4, and right 1, up 4. And again, connect the dots. Remember, we want to go going towards the right on this one because our 0, 0 point is that point. We can't go past it for x. We can't plug in negative numbers, and that shifted right up here. So I'm going to go right like that, something like that. Then when I go to fill in domain and range, I'm looking for the lowest value for x, or which point is all the way to the left. That happens to be here. That x value is at 1. Okay, so I have 1, and then I'm going all the way to infinity. For the y values on this one, we have this little arrow here. I'm looking, again, starting lowest to biggest. I want the lowest number for y first. In this case, the lowest point on my graph actually comes from the arrow. Not only is that arrow going to the right, but it also has a slope that's going down. So my lowest y value is actually negative infinity because it goes forever and ever. And then when I look for the highest y value on the graph, that's way up here, that point I already circled, that y value is at 4. So I would go negative infinity to 4 with a bracket. Next, we have describing our transformations. So this one right here, this is h equals negative 8, or this would be a shift or a translation left 8. Then we also have the number in front, that 4, since it's greater than 1, that's what we call a vertical stretch. And I'm sorry for that horrible writing there. Hopefully you can understand it. Vertical stretch. Okay, on to number 4. This one has a k value only. That's k equals 2 because it is not in the square root with the x. That means we're going to shift up 2. We also have this negative in front, which is going to cause us to reflect. When we did parabolas, that was instead of going up when it was negative, it went down. It's the same concept. So this is going to shift us. That's going to reflect down, or we could call it a reflection. And that's it for that one. Onwards. Find the inverse of the function. First thing is to change that f of x into a y. So I have y equals x minus 1 parentheses to the 5th. Then I do the Freaky Friday switch. And then I want to solve it for y. So I'm going to do that in my next step here. So to solve this for y, I would fifth root both sides. Fifth root to get rid of a fifth power. And do that on both sides. On the right-hand side, the fifth and fifth root cancel. I just have y minus 1. On the left, I have fifth root of x. And then I'm still, again, solving for y, so I'm going to add 1 to both sides. When you do the add 1, keep in mind it can't go in that root, so keep that fifth root of x separate from the plus 1. Then I have y solved for. I'm just going to change my notation. Instead of y, I'm going to write f inverse. A little nicer than that. Great, so f inverse of x. And since y was equal to all this stuff right here, that's what I'm going to put right over there. So I'm going to say the fifth root of x plus 1. So there's my inverse function. And then I'm going to copy that right over here. That was f inverse of x equals the fifth root of x plus 1. My original function was f of x equals, what was it? The x plus 1 minus 1, excuse me, was x minus 1. Sorry, there we go. X minus 1, all that to the fifth power. So in order to verify that f inverse is the inverse, we have to do what we call Fogg and Goff, the f of g of x, and g of f of x. And we did it mostly with g's, but this is the same thing. If it bothers you that it says f inverse, you could just kind of make a note to yourself. That's the same as saying g of x and just rename the function so it's a little easier. That's fine. Otherwise, what you're doing is the same thing, just using f inverse. So f inverse of x and f inverse f of x. So whichever way you're more comfortable with, it doesn't matter if you do this version or this version, but you have to do the whole row. So either the top row or the bottom row. I'm going to stick with the f inverse notation, but again, whatever you're most comfortable with. So I'm going to do f inverse, which means I start with my f of x function, which says parentheses. Instead of x, I'm going to put in new parentheses, minus 1 to the fifth power. So this is the f of x function. I just replaced the x with parentheses right here. So then I'm going to substitute for x the f inverse function, which says the fifth root of x plus 1. So in there, I don't really need those inside parentheses, so I'm